All right, so here we have cosine, we also have sine, it's all in the same equation. And one thing that we can try to do is we can try to, as the example says, rewrite it so it's all in terms of the same trig function. That might make it a little bit easier on us. And we could play around with this several different ways, but because I see sines and cosines, this sine isn't squared, but this cosine is. And so I'm thinking, if I'm trying to get everything in the same, I'm going to try to use my Pythagorean identity. And if I solve for cosine squared, which is what I have right here, cosine squared would be 1 minus sine squared. So I'm going to replace that. It's 2 times. It was 2 times this, so it's 2 times my parentheses, 1 minus sine squared x minus sine squared x minus 1 equals 0. I have to keep everything else the same. I'll distribute the 2, so I have 2 minus 2 sine squared x. Sorry, this was just a regular sine of x. Whew. Gotta be careful, don't want to keep those mistakes. Gotta fix them when you see them. That's just a regular sine of x minus 1 equals 0. Of course, 2 minus 1 is just 1, so I'm going to write that 1. Actually, I'll put it down here. So we have negative 2 sine squared x minus sine of x plus 1 equals 0. Now, for my preference, when I see most of the things, especially my leading term being negative, I want to multiply everything by a negative 1. Cleans it up. 2 sine squared x plus sine of x minus 1 equals 0. Now, notice how this is in a quadratic form here. Squared, and then no exponent at all. So I'm going to try to factor this. I know this would be 2 sine of x, and sine of x would have to be my leading terms to multiply to get 2 sine squared of x. I believe if we put a plus 1 here and a minus 1 here, that has now factored our expression. Negative 1 times a positive 1 is a negative 1. 2 sine of x times a positive 1, sine of x times a negative 1, those would add together to get just a positive 1 sine of x. So now I can use my zero product property. 2 sine of x minus 1 equals 0. Sine of x plus 1 equals 0. Solve each of these. What values for sine give me a positive 1/2? Well, that would be pi over 6. That would also be 5 pi over 6. Sorry. Yes. Yep. Pi over 6 and 5 pi over 6 over here. What values for x give me a sine value of negative 1? That would be 3 pi over 2. Yeah, I can't think of any others. That'd be it. So those are our values on the interval from 0 to 2 pi. Pi over 6, 5 pi over 6, and 3 pi over 2. Now, it's always good practice to plug these in, make sure they actually do work. So you can always plug those back in, make sure they work, they do. But we can plug those back in individually. Cosine of x, plug it in for sine, and it should come out to be 0. All 3 of these do work, though. All right, here we've got cosecant of x minus cotangent of x equals 1. Whenever we start getting into the cosecants and the cotangents and secants and all that stuff, it's just, we don't really understand it as much as we do just good old sine and cosine and tangent. So you have to be careful, take your time with these. The method that we're going to try on this one is to actually square both sides. So I added the cotangent of x to the other side. And notice that cosecant and cotangent, those are both related in their Pythagorean identity. Their Pythagorean identity, of course, would be 1 plus cotangent squared equals cosecant squared. So when we want to relate these, well, maybe we need to square both sides. Maybe that's what we need to do. Maybe that will give us something to work with. So we have cosecant squared x equals 1 plus 2 cotangent x plus cotangent squared. If I want to get this in all cotangents, I can replace cosecant squared of x with a 1 plus cotangent. That is 1 plus cotangent squared. Okay, now we're working here. If we subtract 1 from both sides, those 1's are gone. If we subtract cotangent squared x from both sides, those are gone. We're left with 0 equals 2 cotangent x. Divide by 2, 0 equals cotangent of x. When does cotangent equal 0? Remember cotangent? It's cosine over sine. If we want it to be 0, we want our cosine value to be 0. And our cosine value of 0 is at pi over 2, or 3 pi over 2. That is when our cotangent of x is going to be 0. But like I said, it's good practice. Go back, plug it back in. This is a very simple one. We should definitely check this to make sure both of these values work. So if we put in pi over 2, cosecant of pi over 2, well, cosecant, reciprocal of sine, the sine value at pi over 2 is 1, right? Yeah. The sine value is 1, so if I'm plugging this back in, that would be 1 minus the cotangent value. We know cotangent of pi over 2 is 0, and 1 minus 0 indeed does give us 1. So this one checks out. That works for sure. But let's plug in 3 pi over 2. The cosecant of 3 pi over 2, well, the sine value at 3 pi over 2 is a -1. The reciprocal of -1 is going to be -1 minus 0. Does not equal 1. So this actually doesn't work, and we have one unique value on the interval from 0 to 2 pi that works. It is just pi over 2. That is our only solution to this on the interval.